Hello and welcome to this film, which is all about trying to show covalent bonds forming using electron dot diagrams. Now hopefully you've seen the film about ionic electron dot diagrams earlier in the series. It's important to realise that these electron dot diagrams are really quite different to those, but hopefully by the end of this film you'll know a set of simple rules that we can follow every time we're drawing a covalent electron dot diagram, and we'll practice using these rules by doing a few different examples. Now, what I'm going to do here is I'm going to tell you what the rules are first. They might seem a little bit obscure, but hopefully we can use them every time we do one of the examples later on. So here's step one. We're always going to, first of all, count the number of electrons that we've got so that we know how many pairs of electrons we have to use. Counting electrons should be simple because we just look up what group an element is in, and that tells me how many outer shell electrons there are. If we've got a charge, so for example, a positive charge means that we've lost an electron, or a negative charge means that we've gained some electrons, then we need to factor that into our counting of electrons. Okay. Step two is to join all the atoms to the central atom using single bonds. Okay, single bonds being shared pairs of electrons, remember. Okay, because these are covalent bonds we're trying to draw. Okay, once we've done that, we'll fill the outer shells of all the atoms in our diagram, okay? Bearing in mind that most atoms have 8 electrons in their outer shell, but hydrogen only has 2, so 4 pairs or 1 pair. And then finally, we're going to count up how many electron pairs we've used, and if we haven't used the amount that we started with, then we'll add some double or triple bonds to our molecule if necessary. Okay, so they're the rules. As I say, they might seem a little bit obscure at the moment, but here are some examples to see if we can put them into practice. So here's 5 of them, 5 examples of different covalent molecules, and we'll see if we can use these rules to figure them out. Okay, so let's start off with the chlorine molecule, Cl2. We've got 2 chlorine atoms here, so 2 times 7 electrons because we're in group 7. Okay, so that's 14 electrons. If I divide that by 2, that means I've got 7 pairs of electrons to work with. Okay? Now, I've got to join all the atoms to the central atom using single bonds. Now, there isn't a central atom here because I've just got 2 atoms. So I'm going to join them together using a single bond. So there's 1 pair of electrons used. Now I'm going to fill the outer shells of all the atoms using the right number of pairs of electrons. Chlorine has room for 8 electrons in its outer shell, so it has 4 pairs. So it's got 1 there, give it another 3 pairs. I could draw these as individual electrons, so I could be drawing pairs of dots or pairs of crosses, but lines is a bit quicker really, and a straight line is understood to mean a pair of electrons. This chlorine atom also has a pair of electrons in its outer shell at the moment. I give it another 3. It's now got a full outer shell. It's got 4 pairs of electrons in its outer shell. Now what I do is I count up the number of electron pairs that I've used. 1, 2, 3, 4, 5, 6, 7. I compare that to how many I started with, and I decide, well, I've used the right amount, so I must have drawn a correct electron dot diagram. Okay? Notice here that each chlorine has formed 1 bond. Chlorine has 7 electrons in its outer shell, so it can accept 1 electron. It can therefore form 1 bond. So that's a useful check to see that you've done something right. Okay, let's do nitrogen next. Nitrogen has 2 nitrogen atoms, so 2 times 5, because nitrogen is in group 5, so that's how many outer shell electrons we've got. That's 10 electrons, so we've got 5 pairs to play with. Now this time I'm going to join my 2 atoms using single bonds, and I'm going to fill the outer shells of all the atoms like I did before. Okay, nitrogen can also hold 4 pairs of electrons in its outer shell. Now I've used 7 pairs of electrons, and I only had 5 to start with. But if I put a double bond between the nitrogens, then that will mean they've each still got 4 pairs of electrons, but I've now cut down the number of electrons that I've used. I've now got 6. That's still not good enough because I've only got 5 to play with. So if I put a triple bond in now, 3 pairs of shared electrons, I'm left with 1 lone pair or 1 non-bonding pair on each of the nitrogens, and each one has still got 4 pairs of electrons. So by inserting multiple bonds, I'm making sure that the nitrogen still have the same number of electrons, but I'm using fewer electrons. Now I've used 5 pairs, so I'm done. Okay. Silicon tetrachloride. Okay. We should know how to name these things from the introductory films, but silicon is in group 4. I've got 4 times chlorine, so that's 4 times 7. So altogether I've got 32 electrons, and that's 16 pairs. Okay, so I've got 16 pairs to play with. I'm going to attach all the atoms to the central atom using single covalent bonds. How do I know which is the central atom? Well, it's usually the first one listed. Sometimes you'll see, like in water, hydrogen is listed first, but if you think about hydrogen can only form one bond because it's only got one electron. It's never going to be a central atom if there's more than one atom around. More than 2 atoms around, I should say. Okay, so anyway, silicon is the first in our list, so we're assuming it's central. We'll put them in the middle, and we'll join all the chlorines to the silicon using single bonds. We'll now fill the outer shell of all the atoms. Silicon already has 4 pairs of electrons, so it's full. I'm going to give chlorine 4 pairs of electrons by giving each one another 3 pairs. Now, how many pairs have we used? Well, there's 4 here, 4 here, 4 here, and 4 here, so that's 16 pairs, and there's my electron diagram for silicon tetrachloride. Doesn't matter what angles these bonds are at, that's not important. What's important is making sure that each atom has the correct number of electron pairs around it, and we've got the right number of bonds. Moving on to sulfur dioxide. Sulfur's in group 6. Oxygen is also in group 6, but I've got 2 of them, so I've got a total of 18 electrons. That's 9 pairs. So if I join all the atoms to the central atom using single bonds, like the rule says. Remember, sulfur is our central atom because it's the first one in the list. Okay, now I fill all the outer shells of electrons. So I've given sulfur 4 pairs by adding another 2. I'm going to give each oxygen another 3 pairs because each one of them had 1 already. Let's count up the electron pairs. I've got 4 here, I've got 4 here, and I've got another 2 there. So that's 10. That's no good. But remember, if I stick a double bond in, so let's say stick a double bond in between that oxygen and the sulfur, I've now got 2 electron pairs around the sulfur here. I give it a lone pair and a bonding pair here that it already had. So I've basically used up these 2 electron pairs by forming a double bond. I've cut down on the number of pairs. I've got 9 pairs now, so I've finished. I've done the job. Okay, so we've got a double bond and a single bond here. If you're asked how many lone pairs there are in the molecule, you have to count up how many pairs you've drawn that aren't involved in bonds. Okay, last example is the nitrate ion here. So we've got nitrogen, which is in group 5. We've got oxygen times 3, so that's 6 times 3. And we've also got a negative charge, so there's another 1 electron. Okay, so altogether I've got 18 plus 6, so that's 24 electrons, so that's 12 pairs. Maybe pause the film here and see if you can do it yourself, but here's how it's done. So we're going to put the nitrogen atom central, okay, because it's the first in the list. I'm going to join all the oxygen atoms to it using single bonds, and I'm going to fill all the electron shells, remembering that nitrogen has 3 here, so I'm going to give it 1 extra. Count up the electron pairs. I've used 13, but I only had 12 available, so perhaps let's turn those 2 pairs into a double bond here. Okay, and that will mean that we've got a double bond up there, 2 lone pairs on that oxygen now, single bond down here, single bond down here. And now, remember, because this is an ion, it needs to be in a square bracket so that the charge that we draw applies to the whole ion and not to any one particular atom. Okay, so we've done a few different examples there, some with single bonds, some with multiple bonds, some with single and double bonds in them, and also examples with charge. Hopefully it all makes sense. Hopefully you understand how the rules work now, and you can draw electron dot diagrams for covalent substances. It's absolutely crucial to get some practice with this so that you can check that you understand how to do lots of different molecules. Get some practice without doubt, but hopefully the practice that we've done makes sense. If you've got any questions or comments, please feel free to post on YouTube or to come and find me and to talk about things in person.